Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May June 2023, Paper 4, Variant 2. In today's lesson, we will talk about mechanics, we will discuss thermal physics, we will also talk about waves. As always we will do these questions in detail so you can improve your conceptual understanding of mechanics, conceptual understanding of thermal physics, and also conceptual understanding of waves. And also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 3 part A says figure 3.1 shows a person moving across an ice covered pond to reach a ball on the ice. Explain why this way of moving across the ice is safer than walking. Use your understanding of pressure in your answer. This question is pretty straightforward. This is about pressure. In order to answer this question, first thing we need to understand, if the person is lying on the ice and if the person is walking on the ice, weight of the person is the same. Means the total force exerted by the person on ice is the same. So we can write down the first point. We can say weight of the person is the same. It doesn't matter person is lying on the ice or person is walking on the ice. So it means that the force on the ice is the same. So weight is the same, so force on the ice is the same. Now we need to understand when ice will not crack, means when ice is less likely to be cracked. Ice will be less likely to be cracked if value of P is lower. Crack. So if P is lower, if P is greater, it will crack. So if P greater, ice is more likely to be cracked. So if we can lower P, we can reduce the risk of cracking ice. So how we can reduce P? P is equal to F over A. In this case, F is equal to weight of the person divided by area in contact of person with the ice. If we want to reduce P, weight is the same. Weight of the person will not change when the person is standing, when the person is lying on the ice, but we can increase area. If we increase this contact area, we can reduce P. So these are the points you need to understand. To answer this question is a typical type of question about pressure. So let me show you the answer, how you can write down a proper answer. In order to write down answer for this question, you have to mention these points. First point, you can say force is same, so pressure is lower. So as we mentioned here, force is same, area is larger, so the pressure is lower. Area is larger, so you can mention this point, weight of person is spread over much greater area. So if area is greater, force is the same, P will be lower. So ice is less likely to crack. So these points you need to mention in your answer. So let me explain you one more point. Hold your pen between your index finger and your thumb like this. You will feel more pain on index finger because index finger, you can see this area is smaller. So the pain we feel, that is not only due to the force, that is due to the pressure. I used to tell students that pressure causes pain. So if higher pressure, it means you will feel more pain. If low pressure, you will feel less pain. Part B says figure 3.2 shows a side view of the pond with a layer of ice floating on the water. The surface area of the pond is 5.0 meters square and the mass of the ice is 690 kgs. The density of water is 1000 kgs per cubic meter and point X is 0.45 meters below the ice. Calculate the pressure at point X due to the ice and water. So we need to find out value of P at this point. So first of all, we can say this P is Px. So Px in this case, so simply we can write down here, Px will be equal to P due to water plus P due to ice. So this is first of all we can write down. Now we need to understand how we can calculate P due to water. So we have height of the water, so this is column of water. So P due to water will be rho g delta H. And how about P due to ice? So we have ice spread over this area. So ice is spread over this area. So if you need to find the pressure due to ice, this one has to be equal to F divided by A. Now simply we need to plug in values. We have density of water, that is equal to 1000. We have value of G, that is equal to 9.8, and the height we have, that is 0.45. So simply we can write on here 0.45 plus force over area. Force in this case is equal to weight of the ice. Mass of the ice we have, so we can write down this is mass of the ice 690. We need weight, means the force exerted on this surface, that is equal to weight of the ice. So we have to multiply by g. So this is 9.8 divided by contact area, that is 5.0 meters square. So we have 5.0. Now we just need to simplify. So if we solve here, we will get 4410 plus for ice we will get 1352.4, and if we add these two together, our final answer will be 5.8 times 10 to 3 Pascal. So this is our final answer, and this is how you can approach this problem. A beautiful question about pressure. So we have ice, so we have to consider the total weight of the ice over total area. Let's imagine that if we have only weight of this part of the ice, this is given to us, and area in contact is also given. So you have to use the weight of this part of the ice divided by contact area. In this case we have weight of the total ice, so we have to divide by total area. So this is important point, maybe you will need next time. Question 4 part A says the temperature of a fixed mass of gas at constant volume is decreased. State and explain in terms of particles how pressure of the gas changes. So first of all, for this question it is given to us that delta V is equal to 0, means volume remains constant, and it is also given to us that temperature of the gas decreases. So if temperature of the gas decreases, it means that kinetic energy of the particles decreases. So if kinetic energy of the particles decreases, it means that average speed of particles also decreases. If average speed of the particles decreases, it means that lower rate of collision. So it means lower rate of collision is very important point. Most of the time students, they don't understand what exactly it is meant by lower rate of collision. Let me explain you this one with one simple example. Imagine that we have this container and one particle is at the center. This particle will move this side, it will collide this wall, then it will go back and collide the second wall. But now if the speed of this particle has been decreased, this particle will take longer time to hit one wall than to hit the second wall. So it means that at any given instant of time, less number of particles, or we can say fewer number of particles, they will be colliding with the wall. So it means lower rate of collision. And also as speed has decreased, it also tells us that smaller force by each particle. So we can say smaller force by each particle on the wall. So we can say by each particle smaller force, or you can say average smaller force by each particle. So these are the points we need to understand. I hope this point is clear to you. Now let me show you the answer, how you can write down a nice answer for this question. In order to answer this question, first thing you can say, in this case pressure decreases. So P question was asking you, so P is equal to F over A. Area of the wall remains constant. Just imagine whole wall. So area of whole wall remains constant. If the force decrease, it means pressure will decrease. So these points we need to mention. We can say pressure decreases, particles have lower velocity. As we have mentioned, particle speed is lower rate of collision, and particles collide with smaller force. And so if you write on these points, you will get 3 marks. And this is kind of repeated question. Your concept about this point has to be clear. Means why pressure decreases if temperature decreases and volume is kept constant. For the second part, part B1, we need to state value of absolute 0 in degrees Celsius. At IGCSE level, you can simply say 273 degrees Celsius. But when you will go to AS level, we will state this one more precisely. We will say this is minus 273.15 degrees Celsius. But at IGCSE level, simply if you write on minus 273, you will get mark for this one. For the second part, we need to explain what is meant by the term absolute zero. Refer to particles in your answer. Absolute zero is the lowest possible temperature, and at that temperature, particles have the least kinetic energy. So this is what we have to mention in your answer. So we can simply say for this one, lowest possible temperature at which particles have least kinetic energy. So you have to mention lowest possible temperature, and you also have to say particles have least kinetic energy, because you have to explain this one based on particles. Refer to particles in your answer. So you have to follow instructions given in the question. Part C says cylinder 1 contains 350 cubic centimeters of gas at pressure of 9.0 times 10 to 4 pascals. The gas is transferred to cylinder 2 and pressure increases to 1.6 times 10 to 5 pascals. Temperature remains constant. So for this question, simply we have to use Boyle's law. So we can say P1 V1 has to be equal to P2 V2, because in this case temperature remains constant. You can also derive this one from here. PV is equal to nRT. As temperature is constant, N is constant, R is constant, so it simply means that PV is equal to constant. So we can say P1 V1 is equal to P2 V2. In this case, we need to calculate volume of cylinder 2, so we need to calculate value of V2. V2 will be equal to P1 V1 divided by P2. Value of P1 we have, that is equal to 9.0 times 10 to 4 pascals. So this is in pascals. And we have volume, that is 350 cubic centimeters. We have to divide by P2, that is 1.6 times 10 to 5 pascals. So this is 10 to 5 pascals. Now simply if you look at the units, we can cancel this unit with this one. So we left with cubic centimeters. So if we solve this now, our final answer will be 200 cubic centimeters. So this is our final answer. And this is how you can approach this type of problems. In this case, you no need to convert units into meters. Question 5 part A says figure 5.1 shows an electric heater used to heat a room. The dimensions of the room are given to us and density of air is also given. We need to show that mass of air in the room is 79 kgs. So we need to calculate mass, and mass is equal to density times the volume. Density of air is given, that is equal to 1.2 kgs per cubic meter, and also we have volume, that is 4.5 times 6.1 times 2.4, and this is in cubic meters. Now simply cubic meter we can cancel with cubic meters, so we left with kgs. So if we multiply this one, we will get 79 kgs up to 2 SF. So this is how we need to answer. This question has 2 marks. First mark is the B mark. If you have written this formula, you will get 1 B mark. Mean it, you have to write on this formula. It's very important one, not just simply plug in numbers. Then the second mark is here, this B mark. Mean you also have to show this in your steps. Second part says the power of the heater is 1100 watts. The specific heat capacity of air is 1000 joules per kg per degree Celsius. We need to calculate the time taken to increase the temperature of the air in the room from 16 degrees Celsius to 20 degrees Celsius. This is a typical type of question, so we can simply start with Q. Q is equal to MC delta T. Q is the thermal energy supplied. But in the question, power is given to us, so we can divide both sides by delta T. So we can also divide this side by delta T. So Q over delta T means thermal energy, rate of thermal energy transfer. This is equal to power. So we can write on here, this is MC delta T divided by delta t. For this question we need to calculate time taken, means we need to calculate delta t. So we can rearrange this. We can write on mc delta t divided by power. Now simply we need to plug in values. Mass we have already calculated in the last part, that was 79 kgs. Value of c is given to us, that is 1000. Delta t, rise in temperature. So the change in temperature we have, this is 20 minus 16, so we have 4.0 degrees Celsius, and divided by power, that is 1100 watts. Now if we simplify this one, we will get our final answer, that is 290 seconds. So this is how we can approach this question. So final answer is 290 seconds. A beautiful way you need to understand how to answer this type of problems. Third part says, suggest one reason why the time calculated in A2 is the minimum time needed to increase the temperature of the air in the room from 16 degrees Celsius to 20 degrees Celsius. Minimum time, because in this case we haven't considered thermal energy loss, or we haven't considered thermal energy transfer to other objects in the room. For example, in the room we have furniture, some energy will be transferred to the furniture, some energy will be transferred to the curtain, some energy will be transferred to the walls. So energy supplied by the heater has been transferred to other objects in the room as well. Part of the energy is used to increase the temperature of the air. So some energy is used by furniture to raise its temperature, some energy is used by walls, some energy supplied has been used by curtains and other objects in the room as well. And some energy has been lost through windows, through doors. We haven't considered those things. So that's the reason this is the minimum time. But practically time will be longer than time calculated in part A2. So these things we need to understand. So let me show you the answer, or you can write down your answer. In your answer you can mention these points. You can say thermal energy is transferred to furniture and other objects in the room, and thermal energy is transferred to windows and doors from the room. So part of energy is used to increase the temperature of the air in the room. So very important point. So you need to understand this one. When we heat up air, energy is not only used to increase the temperature of the air in the room, energy is used to increase temperature of the furniture. Energy is also used to increase temperature of the curtains, also used to increase temperature of the walls, temperature of the ceiling, and also some thermal energy has been lost through windows and doors. So these things we need to understand. Very nice. Not just to memorize and write the answer, try to imagine, visualize these things. If we go to this part B, for part B, it is given to us figure 5.2 shows a cross section of a double glazed window in the room. State the main methods of thermal energy transfer from the room to outside which are reduced by this type of window. So in this case, simply if you look at this window has glass, and glass is solid. So glass is solid, so thermal energy, this is solid, so thermal energy will be transferred by conduction. So we can say by conduction. So thermal energy will be transferred by conduction. And it is given to us, we have air inside this one. So this one is air. And air is fluid. In fluids, thermal energy mainly is transferred by convection. So we can write down convection. So these points you need to understand. So here we need to write down simply conduction and convection. Conduction and convection. So these points we have to write down for the answer of this question. Conduction and convection. Question 6 says two types of seismic waves are P waves and S waves. For part A, state the types of wave that P waves and S waves can be modeled as. P waves and S waves. P waves mean primary waves. Primary waves cause buildings to vibrate like this, means like this. And these waves are longitudinal waves, so we call them longitudinal waves. And these are the most dangerous one, so we call them longitudinal waves. Primary waves are most dangerous because buildings are not good under tensile forces, mean under tension, but buildings are good under compressive forces. And S waves, they cause building to vibrate up and down. So we call them transverse waves. So those waves can be modeled as transverse waves. So these 2 points you have to write down for part A. For part B, it is given to us the velocity of a P wave in the Earth's solid crust is 7.2 kilometers per second and frequency is this one. We need to calculate wavelength of this P wave. So wavelength, simply we can calculate, this will be equal to V divided by frequency. Velocity is given to us, that is 7.2 kilometers per second, so we have to multiply by 1000 divided by frequency, that is 4.5. If we solve this one up to 2SF, we will get 1600 meters. So this is the wavelength. So simply we have to write on here 1600 meters. Question 7 says figure 7.1 shows a container of oil. A ray of light shines on the surface of the oil. The refractive index of the oil is 1.47. On figure 7.1, draw the normal at the point where the ray enters the oil. So simply we need to draw one line here that has to be perpendicular to the surface like this. Or simply you can draw a beautiful line like this. This one has to be perpendicular to the oil surface. This angle has to be 90 degrees. For part B, it is given to us the angle X is 56, means this angle is given to us, this is equal to 56 degrees. So this one is 56, so this angle has to be 34 because the total angle is 90 degrees. So this angle has to be 34. We need to calculate angle of refraction. Angle of refraction mean in the oil. So if no change in medium, ray has to go like this, but there is a change in medium, so it will bend towards normal. So let me draw again. So it will bend towards normal like this. So we need to calculate angle of refraction. So simply we have to use Snell's law. We can say N1, mean this is over medium 1 and this one is over second medium. So ray of light will go like this. So we have N1 sine of theta 1. This one has to be equal to N2 sine of theta 2. So this is medium 1, this is medium 2. N1 for medium 1 is 1. This is air. So here we have sine of 34 degrees. N2 is given to us. This is equal to 1.47. So we have to find out sine of theta 2. So if we simplify this one, we can write down sine of theta 2. This will be equal to sine of 34 degrees divided by 1.47. So sine of theta 2 has to be smaller than sine of 34. So if we solve this one, theta 2 from here, we will get sine inverse of sine of 34 divided by 1.47. If we solve, we will get 22 degrees. So this is our final answer, 22 degrees. Simply you have to use Snell's law and you have to be careful. Angle of incidence is this one. Angle with the normal means the angle between ray and normal. So we have to take 34 instead of 56. Part C says state the approximate speed of light in air. Speed of light in different media is different. So question is asking you speed of light in air or speed of light in vacuum. Approximately these two speeds are the same, but the speed of light in vacuum is the fastest, but speed of light in air is a bit slower. But at this level we can assume speed of light is the same in air as in vacuum. So we can simply say this is equal to 3.0 times 10 to 8 meters per second. For part D, we need to calculate speed of light in the oil and we need to give answer up to 3 significant figures. So for this question we have refractive index of oil that is equal to 1.47. Now we need to understand refractive index of air times speed of light in air. This one has to be equal to refractive index of oil times speed of light in oil. For this question, we need to calculate speed of light in oil. So this will be simply equal to refractive index of air. So we can say N air, speed of light in air divided by refractive index of oil. So refractive index of air is 1, speed of light in air is 3.0 times 10 to 8, and refractive index of oil, this is equal to 1.47. So simply we need to divide. If you divide by 1.47, you will get 2.04 times 10 to 8 meters per second. Our answer has to be up to 3SF, so this has 3SF. So simply you have to write down 2.04 times 10 to 8 meters per second. So you also need to write down the unit. So this is how you can answer. This is a beautiful way. So try to understand this one. So it's important to understand this. You can say refractive index in medium 1 times speed of light in medium 1. This one has to be equal to refractive index of the second medium times speed in the second medium. You can also see from here, if the refractive index is greater, it means speed in that medium will be slower, and vice versa. That's all for today's video. I hope this video was helpful. If this video was helpful, please like and subscribe, and also leave some comments in comments section. And also, if you have any questions, please leave your questions in comments and I will try to answer as soon as possible. If you need more help from me, and also you want to support the work I'm doing on YouTube, please join Patreon. On Patreon, you can be connected with me more directly. You will be able to ask me more questions, and also on Patreon, I'm arranging weekly sessions. You can also join those weekly sessions for IGCSE physics, for AS physics, for A2 physics, and also for different physics competitions like BPHO, like Physics Bowl from US. And also, if you wanna apply for Oxford University or Cambridge University, I also train students for Oxbridge, mean for Oxford and Cambridge University admission test. And also you can join sessions, training sessions for PAT and ENGA, and also for NSAA for Oxbridge admission test on Patreon. Looking forward to see you on Patreon.